In this lesson, we are going to talk about a second condition known as objects must not be together. When objects must not be together under conditional permutation, how do we go about it? Now let's proceed. When certain objects must not appear next to each other, a common strategy is to arrange the other object first and then place the restricted objects in the spaces created. So the first strategy is that one, you arrange the objects that are not restricted, those that can be separated. Then two, identify the spaces created between these arranged objects, including the ends. Then three, you place the restricted object into these available spaces, ensuring no two are together. So this is very simple. So what they mean is that anytime you have, let's take this example for clarification. So here, in how many ways can 5 boys and 3 girls be arranged in a row such that no 2 girls sit together? Now the condition is no 2 girls sit together. So the first thing you need to do is that one, you arrange the 5 boys first. You are going to arrange the 5 boys first. So we are arranging the 5 boys first. So we're arranging the 5 boys. There are 5 different ways, and that's going to be 5 factorial. Then step 2, arranging 5 boys create 6 possible spaces where girls can sit. Yes, this is what it means. Let's say these are the boys. 1, 2, 3, 4, 5. Let me be very clear here. 4, 5 boys. Now, how many possible spaces can each girl sit? Can any of the girls sit? Now, there is a space in front of this boy. There's a space behind or at his right hand side. There's a space over here. There's a space over here. There's a space over here, and there's a space over here. So counting these spaces give a total of 6 spaces. So the next thing is that we are going to basically fill these 2 girls. We are going to fill these 3 girls. We are going to fill these 3 girls in these 6 spaces. So how many possible ways can we do that? So step 3, we need to place 3 girls in these 6 spaces. This is a permutation problem, yes, because we are choosing one girl at a time. And then what happens is that these 3 girls, how many ways can they be arranged? Please, one important caveat that you always have to be cautious about is that anytime you have a question, permutation mainly deals with arrangement. Whereas combination deals with selection. In selecting objects, order of the selection do not matter, order of arrangement do not matter, order of selection do not matter. Anytime you have permutation, you mostly see arrangement where order is important is permutation. So arrangement, anytime you have a question and then it's about how many ways can this object be arrangement, think about permutation. So here we take the permutation of 6 spaces, taking 3 girls at a time. How many ways can this be filled? So we use this approach, and then we have this factorial. And as I said, anytime you have a number of ways, the total, so here 6 is for n. In the previous where we said that permutation is equal to, that's n and then r, where n denotes the total number of objects, or in this case we are dealing with spaces, and then r, the objects that are going to be taken at a time. So we are taking 3 girls at a time. Now we are not basically concerned with the number that we are taking at a time, but then how many, the n. Okay, so the n is the total, and then the r is the number that we are taking at a time. The n is the number that we are taking at a time. So here, so the n is the total number and r is the number that we are taking at a time. So when that number is taken from n, how many remains? So here n is 6 and then r is 3. So how many remains? So 3 remains. So we take 5 factorial, we divide the total number, we take the total number factorial over the number that remains after taking that number of objects at a time. So here, that's why we have 3. So 6 minus 3 is 3. So we have 6 factorial over 3 factorial, and we got this. Now after that, since we are to ensure it is in sequence, because we have 3 girls, and then they are being arranged among boys. So a girl comes, a boy comes, a girl comes, and then a boy comes. So those are the sequential arrangement. Therefore we use multiplication principle. So after that, we multiply. You have to multiply the total that is 5 factorial of the boys that are not restricted, and then also you find. So here the difference is that we did not add the number that are not together. We did not assume them to be 1. Rather, we just find the factorial for the boys that are not restricted, and then also we found the number of spaces where these 3 girls can fill, and after that we multiplied by the total number, which is the 5 factorial, the boys, and then we obtain 14,400 possible ways. 14,400 possible ways. So that's another way of, or that's another condition under permutation, conditional permutation. Thanks for watching, and let's meet in the next video. Bye.